Let us see different cases where we are going to find apparent weight of body in lift. First case, we are going to find for no acceleration or constant velocity. Before that, let us take a man. He is standing in the lift, and inside the lift he is standing in the weighing machine, and he is exerting a weight in this way on the machine, and the machine is also exerting the reactionary force R in the upward direction. And this R reactionary force, the force of reaction, is equals to W. Now in the first case there is no acceleration, that means the lift is moving up or down with constant velocity. We know net force is equals to mass into acceleration. So what is the net force? It can be R minus mg. R is nothing but a weight. R is equals to W. That point we should remember. So here we are considering R is acting upwards and mg is acting vertically downwards. So R minus mg equals to mass into acceleration. So here there is no acceleration. So this term is 0. So R equals to mg. If R equals to mg, then W is equals to mg. So the machine will read mg as the weight of the person. Let us see two more cases. So in this case, the lift is moving up with constant acceleration. So if it is moving up with constant acceleration, also mg is acting vertically downwards and the reactionary force R is acting vertically upwards. So we have to frame the equation R minus mg equals to mass into acceleration. Why? Because it is moving upwards with acceleration A. So the upward force must be greater. So R minus mg is equals to mass into acceleration. R is equals to m into g plus A, or weight is equals to m into g plus A. That is the weight read by the weighing machine. So here we can see the apparent weight W is equals to mg plus ma. That is mg added by some quantity m into A. So the apparent weight is increased than mg. W apparent weight is more than mg. So apparent weight is greater than mg. So the person will feel his weight to be increased than the normal condition. In normal condition, his weight will be mg only. But when it is moving upwards with constant acceleration, when the lift is moving upwards with constant acceleration, then he will feel his weight to be increased than normal state. Let us see another case where the lift is moving downwards with constant acceleration. If it is moving downwards constant acceleration, then the equation will be like this: mg minus r equals to m into a. Why? Because it is moving downwards with constant acceleration. So mg must be greater than r. So only then it will move downwards with constant acceleration a. So in that case, mg is greater than r. So mg minus ma is equals to r. The downward force is greater, so it is moving downwards with some acceleration. Mg minus ma equals to r. R is equals to m into g minus a, or W is equals to m into g minus a. This is the weight read by the weighing machine. Now we can see weight is equals to mg minus ma. That is actual weight mg minus some quantity. Some quantity has been reduced. So his apparent weight will be lesser than mg, or lesser than the actual condition. Mg is the actual weight, so his apparent weight will be less than mg. In such a case, the person will feel his weight to be decreased than the normal condition. So when the lift is moving downward with constant acceleration, he will feel his weight is decreased than the normal state. Let us see two more special cases of same. The lift is moving down only. So if the lift is descending, that is, it is coming down, in such a case where the string is broken. So if the string of descending lift is broken, then it will be like a free fall. It is similar to the case of free fall. In that case, acceleration will be equal to gravity. The acceleration is nothing but acceleration due to gravity. So we know the apparent weight is equals to m into g minus a in case of the lift moving down with constant acceleration. But here a is also equals to g. So it is w equals to m into g minus g, that is equals to 0. So apparent weight is 0. The machine will read 0 weight. There is no weight. So in this case, the person will feel the state of weightlessness. So he will not experience any weight. It is state of weightlessness. Let us see another special case. If the acceleration of descending lift is greater than acceleration due to gravity, that is, we have seen that is W is equals to m into g minus a. Here, if acceleration, this is a special case, if acceleration is greater than this g, if acceleration, so generally the value of g is 9.8 meter per second square. If acceleration is greater than that, for example 12 meter per second square, then this whole value will become negative. Okay, if a is greater than g, then the weight will be negative. So in such a case, the person will rise from the floor of the lift and stick to the ceiling of the lift. So this will happen when a is greater than g, person will rise from the floor of the lift and stick to the ceiling of the lift. Thank you.